You know, when you tune an old school radio, you're looking for that one clear reception.
Right, that perfect, crisp signal.
Yeah, exactly. Because if you're stuck right between two stations, you just don't get the best of both worlds.
No, you definitely don't.
You just get this chaotic, frustrating static. You can't hear the melody of the music. You can't hear the news broadcast. It's just noise, and, well, it's practically useless.
Because the receiver simply cannot process competing frequencies. The signals cross, the hardware gets totally overwhelmed, and the output is paralyzed.
And we instinctively twist the dial to get a crisp, clean signal. But what if I told you that right now, inside your own body, you might be broadcasting that exact same chaotic static to your muscles?
It's a very real possibility for a lot of people.
It really is. Today's deep dive is into a truly fascinating pre-publication manuscript by retired Senior Associate Professor Emeritus Dr. Peter S. Murano. And our mission today for you, listening right now, is to decode a completely new, science-backed framework for how we exercise as we age.
It's incredibly relevant research.
Yeah, because we all know the standard drill, right? We need cardio for the heart, and we need strength training to keep our muscles strong.
That's the conventional wisdom.
But Dr. Murano suggests that by trying to do it all at once, we might be sending our muscles mixed messages that actively ruin our results.
And the clinical reality outlined in Dr. Murano's text takes that radiostatic metaphor to a literal cellular level. I mean, we are facing a harsh physiological cliff as we age.
It's not a fun cliff to think about.
No, it's not. We experience progressive declines in skeletal muscle mass, mitochondrial function, and overall metabolic efficiency.
Sarcopenia, right?
Exactly, sarcopenia. And this isn't just an aesthetic issue of losing muscle tone. Dr. Murano's data notes that this profound loss of functional capacity correlates directly with an increased risk of falls, higher morbidity, and just a devastating loss of independence for older adults.
Which is why everyone says, go exercise.
Right. Exercise is universally recognized as the absolute best non-pharmacological intervention we have to fight this. But a massive problem plagues the data. Older individuals have highly variable responses to exercise. Some people respond beautifully, while others, they put in the exact same physical work, but just don't see the physiological adaptation.
Wow, that has to be incredibly frustrating.
It is. So today, we are exploring the biological why behind that variability and how fixing that internal radio dial can change everything.
Okay, let's unpack this. Before we can figure out why an exercise routine might be failing us or just generating that useless static, we really need to understand the broadcasters.
The cellular directors, so to speak.
Right. We have to look at the two central biological regulators constantly competing for control inside your muscle cells.
These intracellular signaling pathways act as the ultimate directors of your biology. I mean, they determine precisely how your muscle cells will respond to whatever physical stress you put them under.
And the two heavy hitters we are looking at today are mTOR, that stands for mechanistic target of rapamycin, and AMPK, which is AMP-activated protein kinase.
That's right.
To make sense of these really complex proteins, I want you listening to imagine your muscle as a sprawling, bustling city.
I love this analogy.
It helps, right. So mTOR is your heavy construction crew.
The builders.
Exactly. When it gets the right signals, like the intense mechanical loading from lifting heavy weights or a big influx of amino acids from your diet, mTOR clocks in and just goes to work.
It starts building?
Yeah, it builds skyscrapers, it adds physical mass, it's responsible for hypertrophy or muscle growth. Its entire biological imperative is to expand the city limits.
And scientifically, mTOR, specifically through a protein complex called mTOR-C1, functions as the primary driver of anabolic adaptation.
Anabolic meaning building up.
Right. Dr. Murano's manuscript highlights how mTOR-C1 stimulates protein synthesis, ribosomal biogenesis, and structural remodeling. When the body senses an abundance of nutrients and mechanical tension, this pathway initiates the creation of new tissue. It is the ultimate cellular builder.
So that's the construction crew. Now, on the other side of town, you have AMPK.
The maintenance crew.
Yeah, AMPK is the city maintenance and sanitation crew. And this crew, they do not care about lifting heavy things. They get activated by metabolic stress.
Things like endurance cardio.
Exactly, running, cycling, or being in a state of energy deficit. When AMPK clocks in, it boosts the city's energy grids, which are your mitochondria.
Keeping the power on,
Right. And crucially, it goes around tearing down condemned buildings, sweeping the streets, and recycling old, damaged cellular materials.
which in biology, that cleanup process is called autophagy.
Autophagy. So you've got builders and you've got cleaners.
Exactly. AMPK functions as a cellular energy sensor. When ATP, the energy currency the cell runs low during endurance exercise, AMPK activates to restore balance.
By building more power plants.
Yes, it promotes mitochondrial biogenesis, and as you mentioned, it drives autophagy. Now, because one pathway builds things up and the other breaks things down to recycle them, they're often described in older scientific literature as antagonistic.
Like they're fighting each other.
Yeah, it looks like a turf war. But Dr. Murano's paper makes a crucial paradigm-shifting distinction. They aren't enemies. They are complementary cellular priorities.
That makes total sense.
Right. mTOR promotes the accumulation of structural material, while AMPK supports the metabolic engine required to sustain that material.
Because you absolutely need the towering skyscrapers, but I mean, a city fails immediately if it doesn't have the power grid to run those buildings or the garbage trucks to keep the streets clean.
What's fascinating here is that effective physiological adaptation requires both processes functioning at their absolute peak. You simply cannot have a healthy, highly functional muscle without both mTOR and AMPK doing their jobs.
But there's a catch, isn't there?
A major one. This is the absolute crux of the manuscript. They must occur within the appropriate temporal context. The biological timing of when these distinct crews are working changes the entire outcome of your exercise.
Okay, so if both the mTOR construction crew and the AMPK maintenance crew are totally vital for a functional body, the natural assumption is to just, have them both working all the time.
Which leads us right into the fatal flaw of how most people work out today, particularly as they get older.
Let's talk about concurrent training.
Concurrent training is a widely prescribed model. It basically involves performing endurance exercise and resistance training within the same session, or within a very tight overlapping training window.
I have to play devil's advocate here because this is what we've all been taught is the gold standard.
Oh, absolutely.
You go to the gym, you hit the treadmill for 30 minutes to get your heart rate up, there's your AMPK cardio, and then you immediately go lift weights for 30 minutes to get your mTOR pumping.
A very standard routine.
Right. Isn't knocking it all out in one focused 1-hour block the most efficient way to exercise? If you're listening to this and thinking, I only have 2 days a week to go to the gym, I have to do both at once, what is Dr. Murano saying to that person?
Dr. Murano's data offers a harsh truth about whether those jammed concurrent sessions are actually doing anything for your longevity. From a calendar perspective, sure, it is efficient.
But biologically.
Biologically, it is highly problematic. The manuscript outlines a well-documented physiological phenomenon known as the interference effect.
The interference effect.
When you combine both types of training, the AMPK activation derived from the metabolic stress of cardio actively inhibits the mTOR-mediated anabolic signaling.
Wait, the sanitation crew actively blocks the construction crew from doing your jobs?
Mechanistically, yes. You are forcing your cells into a paradox. You are telling them to engage in metabolic stress adaptation and cellular breakdown, while simultaneously commanding them to synthesize protein and build new tissue.
That sounds confusing for the cell.
It is.
Yeah.
At a molecular level, AMPK activation directly phosphorylates and inhibits components of the mTOR-C1 pathway. The signals overlap and contradict one another. The result is attenuated adaptation. You basically water down the specific benefits of both stimuli.
We are right back to the radio static. 2 stations playing loudly at once, and the muscle cell just freezes because it doesn't know what to do with the noise.
And while a 25-year-old might have such robust, flexible biology that they can power through this static and still adapt reasonably well.
Oh, to be 25 again.
Right. But it is a completely different physiological story later in life.
Here's where it gets really interesting. Dr. Murano specifically focuses on why this interference effect is uniquely devastating for aging populations.
It's a critical distinction.
Because it's not just that our muscles get a little weaker or slower as we age, the actual biological signaling gets completely out of whack.
The mechanistic findings on aging skeletal muscle detailed in the paper are quite striking. As we age, our intracellular signaling becomes severely dysregulated.
How so?
Well, aging muscle tends to develop a chronic, low-grade inflammatory state. Because of this, it gets stuck with a persistent, low-level activation of mTOR-C1. It basically loses its nutrient-sensing flexibility. And simultaneously, it suffers from profoundly impaired autophagic processes.
So to go back to our city, the construction crew is just constantly clocked in, stubbornly pouring concrete everywhere without a blueprint, and the garbage trucks have completely stopped running.
That's an incredibly accurate way to picture it. Chronic activation of mTOR-C1 actively suppresses autophagy. Specifically, the manuscript notes that mTOR-C1 inhibits a complex called ULK1.
ULK.
Yes, ULK1 acts as the crucial ignition switch for cellular cleanup. Without that switch, you get a dangerous accumulation of dysfunctional proteins and damaged organelles.
The cellular trash simply piles up inside the muscle fiber.
Exactly. So because the aging muscle already struggles immensely with this signaling clarity, throwing a concurrent training session at it, forcing a massive spike of AMPK and mTOR at the exact same time.
It just creates total cellular confusion.
Total confusion. It actively prevents both proper muscle growth and the desperately needed cellular cleanup.
It's like trying to execute a massive kitchen remodel while a chaotic dinner party is happening in the exact same room.
Good luck with that.
Right. You're trying to install new cabinets while people are cooking, spilling things, and literally nobody is taking out the trash. It's a disaster.
It really is.
So concurrent training for older adults isn't just slightly less efficient. It might be actively preventing the very adaptations they are going to the gym to achieve.
The simultaneous activation of these competing pathways fundamentally reduces the efficiency of both anabolic and maintenance processes. You are compounding the natural signaling dysfunction of aging with artificially induced training dysfunction.
Which brings us to the solution. Because aging muscle is already plagued by this dysregulated signaling and cellular confusion, the answer isn't to just grit your teeth, push through, and work harder.
Definitely not.
The answer is to clear up the communication lines. We have to tune the radio dial to one station at a time.
That forms the core of Dr. Murano's proposed framework, the AMPK-mTOR method. The guiding principle here is temporal sequencing rather than concurrent delivery. We must separate the signals across time.
Instead of mixing the competing stimuli in a single session, you organize your training to create periods of relative signaling dominance.
Precisely.
You dedicate specific days to specific signals. You create an mTOR-dominant session characterized by resistance exercise and entirely separate AMPK-dominant sessions characterized by endurance activity.
That separation is key.
But let me push back on this, or at least ask a critical question on behalf of the listener.
Go for it.
If I do my cardio on Monday, doesn't my body, completely reset by Tuesday morning? I sleep for 8 hours, I feel recovered. How long do these biological signals actually last in the body?
Believing the body resets the moment you leave the gym or wake up the next morning is a fundamental misunderstanding of exercise physiology.
Really?
Yes. The exercise bout itself is merely the stimulus. It's a trigger. The actual physiological adaptation, the transcription of genes, the synthesizing of new protein, the biogenesis of the mitochondria, that all happens during recovery.
So the workout is just a text message to the cell, but the cell is reading and physically reacting to that text message for hours and hours afterward.
That's exactly it. Dr. Murano's paper highlights that muscle protein synthesis isn't an instantaneous flash. It's a prolonged molecular cascade.
How prolonged are we talking?
Following resistance training, mTOR signaling and muscle protein synthesis remain elevated for 24 to 36 hours.
Wow, 36 hours.
And in aged muscle, where processes are inherently slower, the evidence suggests this window could possibly stretch even longer, sometimes up to 48 hours.
Wait, up to 36 or 48 hours of the construction crew actively working just from one heavy lifting session?
Yes, the structural remodeling takes time. And similarly, AMPK-mediated processes, including that crucial cellular cleanup and mitochondrial turnover, persist across extended timeframes following the metabolic stress of your endurance session.
Think about what that means for your schedule. If I do heavy squats on Monday morning, my mTOR construction crew is still heavily active on Tuesday afternoon.
Right, they're still laying bricks.
So if I go for a long, intense run on Tuesday afternoon, I am sending that AMPK maintenance signal right into the middle of my mTOR recovery window. I am causing the interference effect, even though I'm technically working out on different days.
If we connect this to the bigger picture, the goal of the AMPK-mTOR method isn't absolute, 100% isolation of the pathways.
Because that's impossible, right?
Right. As Dr. Murano carefully notes, overlap is inevitable. You simply cannot perfectly silo your biology. Both signals will persist at baseline levels, but the objective is creating periods of relative peak signal dominance.
Peak signal dominance. I like that. You want one voice shouting clearly above the whisper of the other.
By giving each signal its own dedicated day and ensuring proper spacing between them, the muscle can fully commit to anabolic growth under conditions of drastically reduced metabolic interference.
And vice versa.
Yes, exactly. Conversely, it provides dedicated intervals for deep cellular maintenance without growth signals prematurely shutting down that ULK1 autophagy switch.
Yeah.
You are intentionally shaping the cellular environment so adaptation can initiate under the best possible conditions.
Okay, so we've covered the cellular biology. We've got construction crews, sanitation crews, ULK1 switches, and peak signal dominance. So what does this all mean? How do we actually apply this complex science to a practical weekly calendar so that you can use it?
Dr. Murano provides a very clear, biologically plausible blueprint for this. It's about architecting your week to intentionally maintain that oscillation between growth and repair.
What's the rule of thumb?
The absolute non-negotiable rule is keeping one or more days of separation between the competing stimuli between your cardio and your resistance training.
Let's break down exactly what that looks like. For the standard routine, which the manuscript suggests is perfect for most people looking to apply the AMPK-mTOR method and get their health back on track, Monday is an AMPK day.
That's your cardio, your endurance generating that metabolic stress.
Tuesday is a rest day.
You let that signal ride, let the maintenance crew do their deep cleaning for a full 24 to 36 hours.
Wednesday is your mTOR day. Resistance training, lifting weights, giving the body deep anabolic stimulation.
Right.
Thursday is another rest day. Let the construction crew build uninterrupted. Then Friday, you're back to AMPK cardio and you repeat that oscillation. You are intentionally building in those days of separation to achieve absolute signal clarity.
That's the baseline. Now, for individuals who are highly trained, those whose bodies are deeply accustomed to higher volume and possess a faster baseline recovery capacity, the manuscript outlines a more advanced, compressed schedule.
I want to hear this, but I'm already skeptical.
Right.
If we need 36 hours of recovery, how can an advanced routine not trigger the exact interference effect we are trying to avoid?
It's a fair question. In this highly trained scenario, Monday's AMPK, Tuesday is mTOR, Wednesday is AMPK, Thursday is mTOR, Friday is AMPK, Saturday is mTOR, and Sunday is a day of rest.
Wow, back to back.
Yes. Highly trained individuals have a more rapid decay of these signaling pathways. Their bodies process the biological text message faster, allowing them to oscillate the signals daily without massive overlap.
Ah, so they recover faster.
Precisely, provided they still strictly avoid concurrent training within the exact same session.
6 days a week is a massive volume, but the pattern holds. Even in the advanced routine, the competing signals are never happening on the same day.
Never.
There's absolutely no concurrent training. Every single day has a clear, dominant signal.
It requires discipline to respect the temporal sequence. You are giving the muscle a clear, unified directive every 24 hours, rather than a mixed, confusing directive every hour.
I want to speak directly to you, listening right now. Why should you care about re-architecting your entire week this way? Why go through the trouble of separating your workouts and abandoning the convenience of getting it all done in 1 hour?
Is a big shift in habits.
It is. But this isn't just some clever biohack for bodybuilders trying to get bigger biceps. This is profoundly important for how we age. We are talking about maintaining your independence.
Absolutely.
We're talking about reducing the risk of falling, which, as Dr. Murano's data shows, is a massive life-altering factor in longevity. By honoring this oscillation between growth and repair, you are building muscle tissue that is structurally robust from the mTOR days and metabolically efficient and clean from the AMPK days.
That is the true clinical significance of this manuscript.
Yeah.
It shifts the focus from merely extending lifespan to optimizing health span, the preservation of your functional capacity.
The health span over lifespan.
Exactly. Older muscle is characterized by reduced anabolic sensitivity and a diminished capacity for cellular repair. This temporal sequencing directly addresses those specific molecular deficits. It introduces a biologically plausible approach to restoring a signaling balance that the aging process naturally disrupts.
It is honestly a complete paradigm shift. We've always been told that exercise prescription is just about what you do. You know, lift weights, run on a treadmill, or how much of it you do.
Just sweat more, right?
Yeah, exactly. But Dr. Murano is showing us that it is equally, if not more, about the biological timing of your signals. By respecting the AMPK-mTOR method, we can cut through the cellular noise.
We can finally be heard.
We can stop forcing our bodies to listen to two radio stations at once and finally give our muscles the clear instructions they desperately need to thrive.
This raises an important question. If Dr. Murano has shown that physiological adaptation actually unfolds over an extended 24 to 36-hour window of biological signaling, perhaps our ultimate success in preserving our youth and our functional capacity doesn't actually come from the hour we spend sweating in the gym.
Wait, really? Where does it come from then?
Perhaps it comes from how masterfully we architect and protect our days of recovery. The magic isn't just in the work, it's in the space between the work.
The magic is in the space between the work. I love that. When you respect the recovery, when you separate the signals, you let the broadcast come through loud and clear.
No more static.
No more chaotic static, just a perfectly tuned dial, broadcasting exactly what your body needs to hear to stay strong, healthy, and fiercely independent. Thank you so much for joining us for this deep dive. Keep tuning that dial, and we'll see you next time.